Hello and welcome to today's topic, and that we are going to learn will be named as SETs, sets. So, what are sets? Let's go with the textbook definition in itself. The textbook definition says sets is a well defined collection of distinct objects. What does this mean? It is a, let's write the statement down. It's a well defined collection of distinct objects. Okay. Now, what is a well defined collection of a distinct objects? Let's assume there is a classroom of 8 students. Let them be named as A, B, C, D, and E, F, G, H. There is a reason that I have written the 4 in bifurcation like this. Now, in this classroom, let's say A, B, C, and D like cricket as a sport. Okay, cricket as a sport, and E, F, G, H like football as a sport. Okay, now can I group these and make them to be cricket followers and group these and make them to be a football follower? Okay, now the students who like cricket, if they are made into, or if they are grouped into groups of A, B, C, and D in this case, and they are represented by a capital alphabet named as C, because I have named it as C because they like cricket, and they are grouped and separated by commas inside a flower braces. So I have written it this way because this is the actual definition of what a set is. Set is a well defined collection of distinct objects. Well defined. What does the statement well defined means? So there shouldn't be any exception to the definition. For example, if I say let's have a set of beautiful flowers in this case. Beautiful flowers might be different for you and different for me. I say roses are beautiful, and you might say roses are not beautiful in your consideration. So, the element of beauty becomes subjective in this matter. So, that makes a not very defined set, and that cannot be considered to be a well not very defined collection, and that is not defined to be a set. So, set means a well defined collection of distinct objects. So, distinct objects means, as the name goes on, it says every object should be different from each other. Is it right here? A, B, C, D, all of these students are different from each other. And is it a well defined set? We have already defined that these many people like cricket and these many like football. So, it is already defined, and it's a well defined collection of objects. Now, well defined collection of these students is also known to be a set. Okay, let's move on to some other examples. Earlier, you have seen I wrote C as A, B, C, and D. Now, this collection of cricket lovers or cricket fans in that case is represented with an equal to sign followed by a capital variable as earlier mentioned, and these flower braces or curly braces that we call it to be, this is how a set is represented. Okay, this is how a collection is represented and it is known to be a set. Now we will go and see about different types of sets. Okay, let's have a set of natural numbers. What do you mean by a set of natural numbers? It's a basic denotion to note natural numbers with n to be written as starting with 1, 2, 3, comma, so on. So can this be called as a set? Will it satisfy our two conditions, that is whether it's a defined collection? Yes, we have a definition for natural numbers that it starts from 1 and every number is spaced one after the other. Okay, and there are no decimals or fractions involved in this, so it is well defined. And are the objects distinct in this set? 1, 2, 3 and so on. There is no repetition of any numbers whenever it goes up to infinity. So this is also to be considered as a set. Okay, now there are types of writing a set. Now we have already written a set in terms of curly braces and elements separated and so on, and followed by a capital letter, for example A in this scenario. Now there is another way of writing these sets as well. So this form of writing the sets with each of its elements separated by commas is known as roster form. Okay, this way of representing a set with all of its elements separated by commas inside a curly bracket is known as roster form. Okay, now there is another form known as builder form, or it is commonly known as set builder form of writing sets. What is this? So for example, if I write n, as we already saw earlier about natural numbers, n is a set such that it has a variable n inside it, and there goes another pipe symbol. So this symbol, or what does this symbol mean? Let me just make it clear. It is a straight line separating n, and this line is known as, or it is called usually as, such that. Okay, these are shorthands for mathematical expressions. When you write a single line, it is named as such that. So it is pronounced as such that, and n such that n is a natural number. Okay, so this is how a builder form is written for any set. So from this, how do we convert from builder form to roster form? We just list out the elements that are inside this. If you write n is equal to starting with 1, 2, 3 and so on, it becomes roster form of the set. But if you write it in words and in terms of one variable, then it is known as in the builder form. Let's go for some more examples. Okay, we will learn more about the builder form. Some builder form examples will go like, let's say there is some set p such that, p of variable x such that This line means such that x is a number, sorry, let's take x is an integer less than 10, and okay, let there be this case. X is an integer less than 10. Okay, so this is the builder form of the set P. Now, how will I convert it into a roster form? That will be P is equal to starting from, because it's an integer that is less than 10, so the number line will move towards negative infinity as well. So there will be n number of elements up to -3, -2, -1, 0, 1, 2, 3, up to 9, as it is mentioned less than 10. Okay, so this is the roster form of this builder form of this statement. Okay, now if it can be converted from a builder form towards roster form, same can be done vice versa as well. If I have, for example, if I have a set of P to be written starting from 1 to going up to 9. Now, what is this set? How can I convert it into a builder form? So P can be written as a variable, let's take it to be x, such that x is a natural, let's take another statement. Okay, this is something new that I will teach you here. X belongs to n less than 10. So this is how sometimes mathematical statements are made, cut short and made into smaller groups. So this is an expression or a Greek letter that is used in place to define belongs to. So please keep in mind that you can write it this way as well. So what does this statement mean? P is a set in X where X belongs to natural numbers, and as I mentioned earlier, it is used to denote natural numbers that are less than 10. So will this condition actually meet this statement? Yes. So X belongs to natural numbers that are less than 10. Okay, now you know, you have learnt two different variables or two different Greek letters here as well. That is one symbol for belongs to, one symbol for such that. Okay. Okay, so this is one more example of converting vice versas of roster form to builder form, and you can do the same in the reverse order from builder form towards roster form. Now you have known two different forms of writing sets. Now we'll move towards, we'll erase this statement as well. We will move towards different types of sets. Earlier we had an example where P, where we had a classroom where A, B, C and D and E, F, G and H, where we told that A, B and C, D like cricket and E, F, G, H like football. Now, in this situation, we have this well defined that these four of them like cricket and these four of them like football. What if there is a question that says, choose the students from here to make a set where nobody likes either cricket or football. So what set will you make? So will there be any student existing in that set? The answer is no. So whenever there is no student, we can write the set to be an empty set. Okay, so this is name of or the type of a set such that it does not contain any element inside of it. It is denoted to be an empty set like this inside a curly bracket, or there is another denotation using a Greek alphabet named as phi. This means the set doesn't have any element in it, and it is also called as null set. Okay, it is named as null set. The null set doesn't contain any element inside of it. So that is also one of the scenarios that we talked about here. Okay, we will keep this example handy for the further types of sets as well. So we started with one type of set known as null set. What do you mean by a null set? Which doesn't contain any element inside of it, is denoted by phi as well, is known as a null set. Now we have another way of writing sets. Now we know here the sets were A, B and C and D for cricket. So our set C was A, B, C and D. Okay. Now will there be any elements after D inside of this set? No. So it stopped at a finite amount of values inside it. Okay. A, B and C and D. So there are almost 4 elements inside, not almost, there are exactly 4 elements inside of C. Now what happens? This has a finite number of elements inside of it and is called as a finite set. So C equal to A, B, C and D. So this is an example that I'll say for finite set. Now I'll take, we have already seen the examples of including dots inside our set when we wrote natural numbers. So after finite comes infinite set. Okay, what do you mean by infinite sets? When there is no fixed number of elements inside sets, it's known as infinite set. Let's consider a set of natural numbers. It will start from 1, 2, 3 and so on up to infinity. So the number of elements inside the set are not defined. In this case, it is called as an infinite set. Now let's go to one more type of set known as equal sets. What do you mean by an equal set? Equal set, as the name itself says, the element of set 1 and elements of set 2 should be equal. Now let's have a set A to be 1, 2 and 3, B to be 2, 3 and 1. Okay. Now are these two sets equal? Please note that when we wrote the definition of set, we never mentioned about order of placement of elements. So in this case, whether the order is interchanged between 1, 2 and 3, we can always say that A is equal to B. Okay. Have you noted down that even though the order has been changed, all the elements of B are in elements of A and all the elements of A are in element of B. So these are known as equal set. Now I'll erase this and get back to one more type. that is equivalent sets. Okay, you know about equal sets. What do you mean by an equivalent set? Equivalent set is something where the number of elements in set 1 and number of elements in set 2 match. These are known as equivalent sets. For example, let's take A is equal to 1, 2 and 3, okay, and B is equal to 5, 6 and 7. These both are equivalent sets because the number of elements inside it 1, 2, 3, 5, 6, 7. It's 3 for both of them. So A is equivalent to B. Okay. Next will be another type of set that is known as subset. Okay. Next topic will be, what do you mean by a subset? Okay. Let's consider a set of numbers from 1 to 10, 1, 2, 3 and so on up to 10, that is named as A. Now let's take another set B such that it's 3, 4, 5 and 6. Okay. Now in this case, what is the meaning of subset that can you deduce from here is this elements 3, 4, 5 and 6, are these belonging to set A? So these elements are also a part of set A. So these come inside the set A. So what the meaning of subset? You know that we'll speak about sub inspector, or what do you mean by a sub? Sub is a substitute or a lower part of a bigger set. So it is a set is divided into smaller parts. It's known as a sub part or a subset. Okay. Here, let me erase this part and explain over here. And our example here, 3, 4, 5 and 6 are part of the set A as well. So this is denoted by, subset is denoted by B is a subset. So this is the denotion of writing subset of A. So this is the denotion or the notion of how to write a subset. So this means subset. Okay. B is the subset of A. Now let me write it clearly for you. B is the subset of A. This means subset. This is just a notation of how to show subset. Okay. There is nothing new. This should be a U symbol with a dash below it. Now we have known about a subset. Now if B is belonging to A and it's a subset of A, now what will A be called as? A is called as superset of B. So whenever this U is tilted towards A, it means B is the subset of A and A is the superset of B. Please keep in mind about these things and please remember about the superset topics. Okay. Let's go towards the next type of set, that is G. This type of set is known as universal set. What do you mean by a universal set? Let's take the same example of 1, 2, 3 up to 10. Okay. 1, 2, 3 up to 10. Okay. And let's take another set B, which is again a subset of A. This is 2, 3, 4. And let's take another set C again, which is a subset of A, that is 5, 6 and 7. Okay. Now, what do you mean where these sets B and C are taken from? These sets B and C are taken from A as a set. Okay. Let's have a clearer thought of what a universal set is. So, this universal set means a larger set of elements from where smaller sets are extracted from. Okay. Universal set means it's a combination, and that is a canopy or the cover of all the sets that come in terms of this example. The 2, 3, 4 also belongs to A, 5, 6, 7 also belongs to A, and hence it gives out A to be the universal set. Understood? It's a canopy that covers both these subsets. So, A becomes a universal set. Let's go towards another topic. Okay. Now we know, we have learned about different types of sets. They will bifurcate, we have already bifurcated them into different types of sets. Okay. Now, in my earlier case of A, B, C, D, E, F, G and H, okay, here I said 4 of them like cricket and the rest 4 of them liked football. Okay. Here, are these the only possibilities? When you think about real life scenarios, 4 people likes cricket, 4 people like football. Is this the only possible scenario here? Can there be students who like both the sport, who like cricket as well as football? Why not? Yes, it can be a possibility. So, yes, let's assume C and D like both cricket and football. So, they also will belong to this set as well. And there is a possibility of, we already discussed, that neither of them likes either cricket or football. Okay. Whenever that situation arises, whenever there is a common ground between two different sets, that is known as intersection between two sets. Okay. Let's take another example here. Instead of having this, we will take numbers to make it simple for explanation. Okay. We have a set A is equal to 1, 2, 3, 4. And we have another set B as 3, 4, 5, 6. Okay. Now what happens? You can easily notice that there is something common between these two sets, that is number 3 and 4 also like A, number 3 and 4 also like B. Earlier example was alphabets, now we take numbers. So A also consists of 3 and 4, B also consists of 3 and 4. So what happens is there is a common element between A and B. Now this common element is denoted by an inverted U, and this is how the notation for an intersection is defined. So this is the denotion of, or the notion of how A intersection B is written. And what are the elements that are intersecting between A and B, or what are the elements that are common between A and B? So this will be 3 and 4 only. So this is how an intersection is defined or written as well. Now we have another topic known as union. What do you mean by union? Now we told it's cricket and football. Now when they like both the sports, we have a common. That means it should be an and condition. They should like cricket and they should like football. There can also be a condition of they like either cricket or football. The earlier condition was they like cricket and football, so they are included in both of these. But now if the condition changes to or instead of an and, what happens? Cricket or football. So they can, one also is eligible for that, two is also eligible for that, 3 and 4 like both the sports, so they are also eligible for that, 5 and 6 are also eligible, and this 3 and 4 is also eligible. But can there be repetitions inside of a set? No. So there is no repetition inside of the set, and whenever there is an or condition, this symbol is denoted as union. Here this symbol is denoted as an intersection, and here it becomes union. So when you union A and B, it will result out in a set of 1, 2, 3, 4, 5 and 6. Okay, this is the resulting output of intersection and union. So that's it with the class, and let's have a quick recap of what we have learned with the sets. So initially we'll start with the definition of what is a set. Set is a well-defined collection of distinct objects, and out of these sets we found out this has to be distinctive. So we had an example of whether considering beautiful flowers as a set or not, and there it was not a set because beauty was subjective. So we have to have a clear cut of what a set is to be. And next we went to different types of sets based on when there is no element in a set, it is called as a null set, and there was equal sets. When the elements of sets are equal, there was equivalent sets wherein the number of elements in each of these sets are equal, then it is called as an equivalent set. Next we went with finite and infinite sets wherein the number of elements inside the sets were definite, were not definite in infinite sets. And next we had an explanation of what a subset was and what a universal set was. Okay, so this was the basic concept that we learned. After that we moved towards intersection and unions of two sets. Okay, now we will have one more small topic in addition to this known as complement of sets. What do you mean by a complement of a set? Okay. Whenever we have a set, for example, A is equal to 1, 2, 3, 4, 5 and 6. Consider this set. Let there be another set B is equal to 3, 4, 5. Okay. Now we have A as a universal set. We will consider A to be a universal set. Okay. And B will become, yes, the subset. So B is a subset of A. Now what do you mean by a complement? Complement is denoted by a set with an apostrophe, that is B dash. What does this mean is, if B A is considered to be a universal set and B is one of the subsets of A, the elements except the elements of B will become the complement of the set B. That is, you have to eliminate elements of B, that is 3, 4 and 5 from the universal set. That becomes your 1, 2 and 6. So B complement will be the elements that are excluding the elements of B. So hence, thank you guys. I think we have recapped and remembered all the sets and the definition of sets until the complement of sets, and it was nice having a class with you. Thank you very much.